record light says we can go ahead and get started. So our question of the day last time involved plans for the summer, interesting responses. I was surprised at how many of you are going to be working or doing an internship. That's great. So I put up a link last time where you can take the personality test that's going to be part of assignment 7. And I still encourage you to do that. I have put up assignment 7, so under the homework tab now the specification is available there and so forth. And I'm using the responses, for the people who took the test to make a great big data file that has the results for people who've taken it, and a big output file, for example, that shows, so if you take this test, you'll be able to see early, before you have the program working, you can see what your personality result is if you participate. There's some extra links here, like there's a link here to kind of some different links that tell you about these different personality types. This is just for fun if you're interested in kind of exploring it. This test is not a test that the psychology researchers like very much. They think that it's not, that it's more like pop psychology. So anyway, if you're interested, have a little bit of fun. And there's a summary of the results that I have here. And to me, one of the really interesting numbers is that in the general population, the percentage of introverts is around 25%, but so far 77% of the people who've taken this test have tested as introverts. Now, I actually know for a fact that there's a lot of introverts in 142. Maybe not quite that many, but you could kind of imagine that people maybe who are more introverted were more inclined to take the test. But in any event, I encourage everybody to do that. I'll keep posting new versions of that big data file, so you have a chance to have yourself included if you take the test too. A little over 100 people have done it so far. It'd be great to get a larger percentage of the class. All right, so we're going to be finishing up Chapter 7 today, and as I said, I released Homework 7 because, it's Homework 6 isn't due until tomorrow, so I'm putting it out a little bit early, but, I know that people are dealing with a lot of stuff, and so it's kind of nice to be able to try to have a little extra time if you might be able to use that. So anyway, putting it out today, and I'm going to be finishing up then our discussion about arrays. So I have a little program file here that has a couple of methods that I want to talk about first. So I have here a method called apply ABS. So the idea is I've set up an array that has some negatives, some non-negatives in it, and I want to kind of do an absolute value. I want to get rid of the minuses, the negatives. I want to kind of turn it into something that they're all positive. So that's kind of the idea of apply absolute value. We'll get to the string one in a second. Let me go ahead and compile and run this version of it. And what it tells us is that, so the data was initially -8, just like it is here, not surprising. And after doing the apply ABS, it's still -8, 274, -54, and so forth. So it didn't work very well, the apply absolute value. Well, that's because I haven't written it. I put in a stub version, so I put in the header for the method, but I haven't written the code for the method. So, again, just kind of reminding you of the stuff we've been discussing for a couple of lectures now. There's a standard traversal loop, actually, before I do the standard traversal loop, let me just kind of talk generally about this absolute value idea. So you know that the math class has a method called math.abs. So like if you had an integer variable x, say, that was -13, you could set x to be math.absolute value of x. And so there is, in the math class, an ABS method that gives you the absolute value of an int. And so we could do that to kind of turn x into its absolute value. It would be nice if you could say something like list equals math.absolute value of list, if the math class had a method like that. Well, it doesn't. There is no such method. But that doesn't mean that we can't write our own method for it. So basically, we know how to given a simple int, we know how to turn it to its absolute value. What we're going to do is we're going to kind of write the method that would be like a math class method that did the absolute value of things. So again, standard traversal for int I starting at 0, I less than list.length, I plus plus. Inside of here, we want to do something with list bracket I. And what is it that we want to do with list bracket I? Well, this is a fancy name, list with the brackets and everything, but remember the point that I made in the very first array lecture, that from Java's point of view, this is just a simple int variable. So it has the same kind of status as x. It's a simple int variable. So if you wanted to turn x to its absolute value by saying x equals math.absolute value of x, just imagine replacing x with list bracket I. So I can say list bracket I is assigned a math.absolute value of list bracket I. So all I did there was I just copied this line of code and did it using list bracket I instead of using x. Well, so suppose we do that. We change the array elements to their absolute value. There's an idea that we mentioned early in the quarter that if you have computed values that need to be used later, then return. That you need a return in order to be able to get those values to escape from this method and to be available to use later on. Well, this is a case where that idea, it does not apply. So that was an idea that we were, putting out there when we were dealing with simple primitive types like int and double, and what are known as the value types that I talked about last time. So remember that what I talked about last time is that, that we use what is known as reference semantics in Java. So this array called data is storing a reference to an array of values. And when we pass it as a parameter, when I pass it here to apply ABS, list becomes a copy of that reference. And I've used many analogies for the reference. You could think of it as an arrow pointing at something, a memory address, a phone number that allows you to get in contact with an object. JGrasp has an object number, so something that kind of identifies the particular object you want to deal with. So list becomes a copy of that. It doesn't get a copy of the array. There's only one array, but we have two references. The data in main and list in the method both are pointing at or referring to or placing phone calls to the same array object. So because of that, we don't need to do a return. So kind of this rule that we had been applying does not apply to arrays. We will see something where there would be a return required, but we'll get to that later in the lecture. So let me go ahead and compile and run this version of it and see how it behaves. And you can see now that the -8 was converted into an 8, the -54 was converted into a 54, and so forth. And that was with apply ABS being a void method that didn't return anything. So having a reference to an array allows you to change the contents of the array. If you are passed a reference to an array, you can change its contents without a return. That's going to be an important thing, an important difference, between arrays and what we were dealing with before with the primitive data. Okay, normally I'd ask for questions, but I don't have that opportunity. I wanted to go over a string example. We've done a couple of these, but mostly when I've gone over these string examples, I've said, well, this is advanced material, you don't have to know quite yet. Well, it's not advanced material anymore. So now this is something that you're going to have to deal with in your next programming assignment. So now it's important. So we're basically doing a similar problem to ones that we've done already, but it's worth doing it then to be able to review. So I've set up a string variable here called hello there that I print out, and then I want to write a method called reverse that gives you the reverse of a string, and I'm setting an S2 to be that. Right now, the main is showing that S2 is set to foo, which is kind of strange. Well, it's because, again, I made kind of a stub version of this, a placeholder version of this. I don't really want to return foo. I just wanted to have something there that would allow the program to compile. So what is it that I'm trying to do? I'm trying to take a string like hello there, and I'm trying to convert it into a new string that has those same characters in reverse order. So this one ended with an E, so this one will begin with the E, and then the R, R, and then the E, and then the H, and then the T, and then a space, OLLEH. So I wanted to return this, if it's past this, to the same characters in reverse order. So that means we're going to need to make a brand new string. So I'm going to say string result equals something. And then we're going to have to kind of put it together. And then we'll do return result. So I'm going to make a string that I'll store in this local variable called result, and then return it from the method. We did something like this before. I think we did a stutter problem where we were kind of creating two of every character. This one is reverse, so it's a little bit different, but a similar idea. Something that's mentioned in chapter 7 is that there's a standard string traversal. And I've mentioned this as well, but I haven't, it hasn't been something that I've emphasized as much that you must understand. But now this is something you must understand because you're going to be doing it for the homework assignment. For arrays, we say for int I equals 0, I less than, here it's going to be a string instead. But if it were an array, we would be saying text.length. That's the way that we would describe it. But I've mentioned before that strings, you don't say length without the parentheses, you say length with the parentheses. It's an annoying detail of Java that the syntax is slightly different for strings, but that's, it's a real programming language that we get to use, so it has some warts, to it that we have to live with. I++, and then inside of here, what I want to do is do something with, now for an array, it would be like text bracket I, but this is for a string, and I've mentioned that for a string, there's a method known as char@, or you might pronounce it differently, char@, or char@I is kind of the string equivalent of what you do with for a traversal loop. So instead of using the bracket notation to index into an array, we use the char@ method to get an individual character. I'm going to store that in a variable, and it'll let me make the point that the thing that we get when we call char@, not surprisingly, is something of type char. So this type was mentioned all the way back in chapter 2, but I said at the time, don't worry, you don't have to worry about it yet, we'll deal with it more later. Well, now is later, so now we're dealing with this. So char is a type, it's got a lowercase letter, it's a primitive type, so it works the int and double do. So I could say char next equals text.char@I. So how about if I kind of put it into a variable just to have a named variable to work with to make that a little bit more obvious what we're going to do. And what I want to do here is something, I'm building up a new string from an old string, character by character, so slowly but surely concatenating and building up a string. This is kind of the string equivalent of a cumulative sum. So in a cumulative sum, we would say that result equals result plus something, and how about plus next? I mean, that would be the obvious thing to be concatenating, is the next character. This isn't going to work, but we'll leave it that way for now. So this is kind of the cumulative sum pattern where we start the sum at 0. Well, the string equivalent of starting at 0 would be an empty string. So I'm making an empty string, I'm going through all the characters inside of a loop, one character at a time, pull out a character, and then concatenate that character to the end of the string. So let's see what happens when I compile and run this version. I get 2 versions of hello there. If I looked carefully, I'd find it is a brand new string. It did make a brand new string. It just made a copy because of the way that I did this. It's exactly the same as the original because of the way I did that. So how do we make it the reverse? I normally ask for suggestions from the class. Lots of different possibilities here. One really kind of obvious possibility would be to just make the loop go backwards, and then it'll be building the string up in reverse order. So we could do that. That certainly would work. It's kind of turn the loop around so that it goes backwards instead of forwards. I kind of prefer, there's a simpler fix we can make that makes this work, and there's usually, several people who see that what we could do is instead of putting next at the end, we could put next at the front. So think about that. Think about what that's going to do. So if I'm going to build up a string, I put an H into the string first. So I'm going in forwards order, but I put an H into the string. But then when I get an E, instead of putting the E here, I put the E here. So I put the E in front. And then when I see an L, I put that in front. And then when I see an L, I put that in front. And then when I see an O, I put that in front, etc. So you can see how I'm building up the reverse string by putting characters at the front. So that's kind of a simpler way. Reversing the loop would be perfectly fine too. Either of those approaches would work fine. But let's see what happens. We're now getting our backwards hello there, which is what we intended. Okay, well, those were two examples that'll be on the calendar for today, kind of just reminding you again about the traversal pattern for arrays, understanding that you don't need to do a return, and then the string manipulation, which, as I say, you'll be doing in your homework assignment. So I want to spend the rest of the time going over a program example. It's a stupid program. It's kind of a dull program. So I'm admitting up front that it's not going to be a fun program. But I designed it specifically to help you get ready for the homework assignment. So that's the good part, is that it's a highly relevant example. I've been trying to do this with the different homework assignments, is to kind of go through a program that constitutes, a medium hint for the homework assignment. And that's true of this example we're going to do today. First let me show you something in the assignment write-up. So here's the assignment write-up. You're doing this personality test, and the personality test ends up asking you a bunch of questions that you answer in an A-B way, and there's a way of figuring out whether you're considered an extrovert or an introvert and so forth. There's one part of this assignment write-up that I think is the single most useful thing in the write-up, which is this diagram right here. Ever since the beginning of the quarter, I've been saying to you that you should be thinking about a development strategy, and you should try to develop your program in stages. Kind of have an identifiable first step to get done, and then write it up, compile it, debug it, get it to work before you ever go to stage 2. So kind of develop it in stages. I've also mentioned that your TAs and fellow students are allowed to give you suggestions about a development strategy. Not code, not how you solve the problem, but how you approach the problem in a development strategy. Well, this one has a very natural development strategy that this diagram right here is making clear. So you begin with a string of 70 A's and B's, a bunch of answers that somebody has given to the personality test. So that's the first piece of information that you're dealing with. And you have to convert that string into 2 arrays of counts. So you're basically counting how many A answers and how many B answers. You'll read about this in the assignment write-up. There's 4 dimensions of this personality test. So you're counting how many A answers versus how many B answers in the 4 different dimensions. And so a really obvious thing to do as a first step is read in the 70 A's and B's and turn it into the 2 arrays of counts and see whether it's doing that correctly. So get that part of it done first before you do anything else, and ignore everything else in the program. So, the string of 70 characters gets turned into 2 arrays of counts. Then the 2 arrays of counts gets turned into a new array of percentages. So that's kind of a next step, is turn, the 2 count arrays into an array of percentages. Do that as a separate stage, test it, debug it, make sure it's working. And then the final step is to turn those counts into a string that matches this personality test. That's kind of the description that you give from the personality test. So this diagram is very helpful, and there's a theme to this homework assignment. This is going to be the most complicated program you'll write all quarter. We're going to have one more assignment, 8, next week, and it'll be hard, but hard in a different way. It's kind of conceptually hard. But this one kind of involves the most complicated code you'll write all quarter. So it's extremely important that you do this kind of development strategy where you do it in stages. And so there's a theme of transformation. Given this kind of data, turn it into that kind of data. Given this kind of data, turn it into this other kind of data. So that's the theme, and that's going to be the theme that I have in this program that I'm going to do with you today. I, in the past, made a handout for this that I would pass out. I kind of stopped killing trees to pass out the handout, and I can't do it anyway under the circumstances. But there will be a numbered handout, number 15, that has kind of, it's showing you the information about this example. So if you're interested, you can see it under the Handouts tab for the course webpage. And I'll put the program up, and the input file up as well, so that you could run it yourself if you wanted to. So the idea is you're given an input file that looks like this, that has sequences of characters, where this is supposed to represent an attendance record for section. Every section you attended, you get a 1, which means you went. A 0 means you didn't go. So this kind of your attendance. It's like Boolean, true or false. 1 or 0, whether you attended. And this is how we record it in Canvas, is, a 1 for you attending, a 0 for you not attending. But you know that gets turned into a section participation score that can be up to 20 points. So attendance tends to get you 3 points. That's, the sections you attend tend to accumulate you 3 points. But at some point, you may have accumulated so many points that you only get 2 points per section. And this person got no points for the last 3 sections, even though they attended the last 3 sections. Now, of course, I would say section's so valuable that it's its own reward. You shouldn't need, extra points. But in any event, this is someone that had a pattern where they just attended everything, and so they kind of quickly accumulated their 20 points, and they didn't accumulate extra points with those later sections. There's other people. Some people never get a 2-point section like this one right here because they never attend enough sections to accumulate the 20 points. So, it's all 3-point sections. And, here's a person who got the 2 points here. Here's a person who got the 2 points here. The person who got the 2 points here. So different people get their 2 points during different weeks. So I want us to write a program that does this conversion. So it's going to be given a string of the 0s and 1s, and it's supposed to turn it into a sequence of scores, which we're going to store in an int array. So this is like the first step of the homework. Given a string, turn it into an array. So that's what we're going to work on. This input file, so it showed you here that this is what the input file looks like. It is a line-based file that we kind of have each line of the file has one person's information. So I want to write a loop that's line-based. We've seen that the way you do that, while input.has a next line, what we can do is to, we want to do that. We'll have a string line, which is input.nextLine. So we'll introduce a loop that reads line by line, one of these lines at a time. And what we want to do is we want to convert the string into an integer array. That's our task. So I'm going to want to have some kind of integer array called scores that I set to be something. This is complicated enough that I want to split it off into its own method. We've been training you to not have too much code in main. So I have in mind that I'm going to have a public static, I don't know what its return type is, a method that I'm going to call compute scores, which is, I don't know what its parameters are yet. But the point is that it's going to do this conversion. It's going to turn something that looks like that into something that looks like that, stored in an array. So that's what I want this method to do. There's an issue that comes up here that I wanted to highlight. So there's kind of an issue of, how to construct an array, or what happens when you go to construct an array. And so one possibility, and this is what we saw over here with the main here, is that main constructed the array and then passed it as a parameter. So one of the things that you can do is this method constructs it and passes it as a parameter. So that's one way to go, is to construct it in this particular method. So not in the method you're calling, but in this method. I'll go ahead and construct the array. I mean, that's what we did here. Main constructed the array and then passed it as a parameter. So that's one of the ways that you can do that. Another way that you can do this, I haven't shown you an example, we're going to do that with this one, is that the called method constructs it. So that's another possibility. There's a nice thing about having the called method do the construction, which is it's nice to have the called method do more. It's nice to take code out of, say, main in this case, and have the method do it. So it's a good thing in general to move this into the method if you can. So that would mean that in here, we would say something like int bracket bracket scores is a new integer array. I don't know how big it is yet. So that could be the way that we approach it, is that it's the method we're going to call that's going to end up doing the construction of the array. But I wanted to talk about an important issue that comes up if you're going to do it in this way. So that means that this method is the one that does the constructing and that is first told the reference to this array. So since it's doing the constructing, it's the one that's going to be told, well, here's where your new array is stored. And so it's got a variable called scores that's got a reference to an array. And the question is, does main have a reference to that array? And the answer is no. So there's nothing special. We saw this with simple variables like ints and doubles. There's nothing special about calling it scores here and calling it scores here. You know those are different. You know that Java ignores the names of those things. That there's a thing called scores here and a thing called scores here. So setting this to be a certain reference does not mean that this one gets that same reference. This is a case where at the very end, we're going to have to return that reference, because this is the method that brought the array into existence. And so it's the only one who knows that reference. So that here it is like what we were seeing earlier in the quarter, where there is something that needs to be remembered later on. It's not that the array values are changing, it's the reference to the array that needs to be remembered. So if you're going to have the called method do the constructing, I'm going to say and returns it. You know, so that's an important thing to understand for this second possibility, is that if the method you're calling is going to do the constructing, it has to return the reference back to you. So as I said, I already showed you an example of the first thing in all the examples we've been doing, but here's one. Is this example we just did with the ABS. So I've given you an example of the number one way to do it. I'm going to write this one in a way that does it the number two way so that we have an example of that as well. Before I do that, I do want to mention that, so in general, I think number two is nicer in terms of having methods do more. So I kind of have a slight preference for doing number two, because that kind of splits off more of the task. But there are going to be cases where you can't do it that way, where the second approach is not available to you. And I normally ask people, think about it. It's because this second approach requires you to return a reference to the array. Remember that you are limited in what you can return. You can only return one thing. Like suppose, you had a guessing, method or something that needed to return the number of guesses. So if that's true, and there was an array involved, it can't return guesses and return an array. So it can't return both of those things. So that would be a case where we couldn't do it the second way. Another example would be if there are 3 arrays to be constructed. You can't return 3 arrays. You can return 1, but you can't return 3. So you'll have to think about it. There are some cases where this second approach is just not available to us. You can kind of always use the first approach. So if This thing is going to be returning an array. That means its return type can't be void. What's its return type? Well, it's returning a reference to an array, and I've been saying it over and over again, but int bracket bracket is the type of that array. So we would use a return type of int bracket bracket. So here we would set scores to be what we get by calling compute scores, with whatever parameter. So compute scores is going to do the constructing and return it back. So that means that this method doesn't need to do the call on new. It's being given back the reference to the call on new that was done by the method. And what is it going to need in order to be able to solve its problem? Well, it needs to know what that line of text was. It needs to know what the zeros and ones are. So it needs to be passed that as a parameter. So it needs to be passed, say, something like this, so that it can construct the array and return the answer. How big should this array be? Well, I think you can tell from what I showed here. The intent is, in this case, it's 10 sections, just like we have this quarter. But if there were 13 or something like that, however many sections there are, we want to have an array that has just as many things in it. So it's converting it from one form of the information to another. And so however many sections worth of information you have, you want to make an array that's just as big. So this array should be just as big as the string is. So this is another place to use line.length with the parentheses. So we can ask for the length of that string, how many characters are in the string, and it'll make an array that's just that size. Then we can say for int I equals 0, I less than scores.length, I plus plus. Well, actually, let me do it this way. Actually, this is a funny one, where I could either write the standard array traversal code, or I could write the standard string traversal code. I really kind of think of it more as processing the string. So let's do it the string traversal way. So let's do I less than line.length. Either of them, obviously could be written in a way that would work. And then in here, do something with line.char@I. So we have to figure out what to do with line.char@I. One of the other questions that I tend to ask people is, okay, we're working with, say, an array like this one here. And we've made, that's the string, and we've made an array that has just as many spots in it. So we say made this array that's 10 spots in it. What's in the array initially? So after I construct it, what's in the array? And the answer is that it's all zeros. Java does this auto-initialization. Everything is set to be 0. So in a way, it already has a lot of the correct values in this array, because the array is populated with zeros initially. So it turns out that any of these zeros that are in the string, we kind of already have the right answer in the array. We have a 0 in the array. So those aren't the ones that we have to deal with. The ones that we have to deal with are the characters that are ones. So that when we see something like a 1 here, this is, I guess, and that corresponds to this entry right here. So the 0 was kind of already set to the correct thing, but when we encounter the 1 that comes after it, we have to set that to be a 3. So what are we going to want to do in here? We're going to want some kind of an if line.char@I is a 1. I'm going to kind of write it that way for right now. If it's a 1, then we need to do something. Now, the reason that I say we kind of had some flexibility in terms of what kind of loop to use is that we are making an array that will have the parallel structure to the string. So whatever's in string element 0 is going to have a score in scores 0. Whatever character is in string element 1 kind of gives a value to scores of 1. String 2 gives a value to scores 2. So there's kind of this alignment here. So if we're seeing a char@I that's a 1, we're going to want to set scores of I. So the whatever the ith value is, if we've seen a 1 in the string, then we want to set the scores to something. For right now, I'm just going to set it to a 3. That's not the right answer, but it's not a bad place to kind of start. is we'll set it to be a 3. So how do we know whether line.char at I is a 1? How do we do that test? Well, we've taught you, well, actually, let me go ahead and do this. What I'm going to do is I'm going to say char next equals line.char at I. So I think it's kind of nice to, char is a little bit unfamiliar to us. So let's just kind of use a simple variable name so we don't have to be worrying about the call on char at. So how do you know next is a 1? If this were a string variable, then we would do dot equals. I've tried to train you always, always, always with strings, use a dot equals comparison. But this is of type char. This is a primitive type like int and double, and so we use equals equals. So that's an important thing. These details were mentioned in chapter 2, but I told you at the time, don't worry about them yet. Now you need to worry about them. Now we need to understand them because you're going to be manipulating characters. So for something of type char, we use an equals equals comparison. And we don't see whether it equals quote 1 unquote. That's a string that's got one character in it, but it is of type string because it's using the double quotation marks. I've mentioned this briefly before, maybe only once, I think, but you use single quotation marks when you're doing type char. So do an equals equals comparison, and you do single quotes instead of double quotes when we're dealing with a char type. So that's different than what we've done before. So if next is a 1, we could set scores of I to be a 3. Let me, for now, just kind of do system.out.println of the scores so that we can see what's in that scores array. So let's see what happens when we compile and we run. And what we get is a whole bunch of gobbledygook. And I did that. I did it on purpose. I actually did today. I don't always do it on purpose, but today I did it on purpose. I was hoping you would think about it and you'd kind of say, that's not going to work. Because remember that you can't just do a simple println with arrays. If you want to see what's inside the arrays, we have to do arrays.toString to kind of get it to convert it into a string that's got square brackets and commas and everything. So to be able to see the nicer version of it, we have to do toString. And now we're getting this. So now that person with perfect attendance is going to get 30 points per section, which is too much. But in any event, it's good that it's doing this much. But we have to think about how do we change the program so that the person with the perfect attendance is not going to get 3 points for every single section. This one, it's really sad because this is one where it's really great to make people puzzle about this because there's lots of really interesting, different answers that I get from people. People will talk about things like, well, maybe you want a counter, to count how many times you've given out a 3, because that, people get 6 scores of 3, right? That gets you up to 18, and then you get 2 more points to bring you up to 20. So maybe a counter would be helpful. That's an approach that you could use. I kind of prefer something a little bit different. The counter still doesn't get at a certain thing that I'm interested in understanding. The suggestion that I kind of preferred, I don't know if any of you are thinking of this, but I kind of want a cumulative sum. So I want to keep track of what does these scores add up to so far, so that as you go through and give people scores, what do they add up to? So here at the end of this loop, I'm going to say sum equals sum plus scores of I. So all I've done is added a variable to keep track of the sum of all the scores. So I'll be adding up all of the scores. So at some point in time, this scores becomes equal to 20. Excuse me, to 18. And that's when we have to pay attention to kind of the fact that we want to cap things at 20. So it definitely involves working with the 20. It definitely involves thinking about that. And one of the questions that I'll ask students to think about is, why a 2? where does 2 come from? How does that factor into things? And if you think about it, if we're doing a cumulative sum, 3, 6, 9, 12, 15, 18, it adds up to 18 at that point. Where does 2 come from? 20 is involved as well. 18, 20, we're trying to find a 2. If you think about it, it's 20 minus the 18. That's where the 2 comes from. It's the difference between this max of 20 and the sum that we have so far of 18. So let me put it this way. Often we want to set scores of I to be a 3, so that is true. But sometimes what we want to set scores of I to be is 20 minus the sum. So when the sum is 18, 20 minus 18 gives us the 2. That's where the 2 comes from. If the maximum score was a 19, then you'd do a 1 instead of doing a 2. It's kind of whatever the maximum is, 20 or 19 or whatever it is, minus the sum. In that one step, that's when we want to set it to be that. So sometimes we set it to be this, sometimes we set it to be the other one, and then when the sum becomes equal to the max, 20 minus 20 will be a 0, and that's actually what we're going to want to set the score to be, a 0, 0, 0 from that point on. So what I'm going to say is that scores of I should be set to one of these two things. You could do an if-else type structure, if it's this or if it's that, but this, that this is a max-min kind of computation. And it's nice to take advantage of the fact that the math class has math.max and max.min. So I've kind of decided, I'm not deciding yet which one it is, but somehow I'm going to choose between a 3 and a 20 minus the sum. I'm going to choose between those two things. Now, what if I took the max of those two things? The sum is initially 0, so 20 minus 0 is 20. The very first section you attended would get you 20 points. Well, that's not how it works. I mean, maybe you'd like if that's how it works, but the max way is not the right answer. That's not the way to go. Well, let's think about min. When sum is 0, then it says which is smaller, a 3 or a 20? 3 is smaller, and then when the sum becomes 3, that 20 minus sum becomes a 17. Which is bigger, a 3 or a 17? Which is smaller, a 3 or a 17? The 3. So it keeps picking 3, 3, 3, 3, 3, until sum becomes 18, and then 20 minus 18 is a 2, and it says which is smaller, a 3 or a 2, and the answer is 2. So then it picks a 2. And then the sum becomes equal to 20, and from that point on, 20 minus sum is 0, and so it's always going to pick 0, because that's the smaller number. So let me go ahead and compile and run that version, and I think I'm going to find, if I compare it against the sample output, like this output right here versus this output right here, they match. That's what I was looking for. Okay, I want to do one more thing, which is if you look at that sample output, I didn't want to have brackets and commas and all of that kind of stuff, so I don't have the correct output yet. This is a minor kind of thing, but I didn't want to be doing just kind of a println of the toString. I wanted to write my own printing method that's going to print this out so that it looks the way that it looked in the sample output, so that it's got spaces between them and so forth. So I'm going to write a little method here that I'm going to call public static void print that takes an integer array that I'll call data. I'm using my scores array, but a more generic name would be data. So for int I equals 0, I less than data.length, I plus plus, standard traversal, do something with data sub I. I want to print data sub I, and then a system.out.println to complete the line of output. And I think most of you know by now, this is going to have them all scrunched together. There'd have to be some spacing in here, so I could add a space, so I get data sub I plus a space. That's going to print an extra space at the end of the line, but that's okay with me. And, we get output here, or we could compare it to the output here, and we find it matches. So we're producing the correct output. I want to show you one more thing with this, though, something that I'm going to ask you to do in your programming assignment. is that I'm going to have you create an external output file. So this is something new, so we can read from an external input file. We can also write to an external output file. So this is something new, and we're going to do it using something known as a print stream. So I'm going to say print stream output is a new print stream. Now, fortunately, it has a very similar syntax to creating a scanner for input. So you put in the parentheses new file, and then the name of the file that you want. Be very careful what you put here. Like if you put personality.java, it's going to overwrite your personality solution. So it erases any old file. So be careful what you put here. I'm going to put output.txt is the name I want to use for this. So this creates a print stream. Boy, and I only have a few minutes left. How am I going to be able to explain to you how print streams work? Well, it turns out that you already know how to manipulate a print stream because you've been manipulating one since chapter 1. System.out is a print stream. So kind of the way that I want you to think of this is I'm going to pass my output print stream to my print method here. So I'll pass in a print stream output. So everything you know how to do with system.out applies to a print stream. So you can do system.out.println, you can do output.println. You can do system.out.print, you can do output.print. So I'm just going to change the system.out to be output. I'm going to just talk to a different object, but in exactly the way I would have talked to system.out. Whatever I would have done with system.out, I'll do with output. And so now let's try compiling and running this version of the program. Oh, it doesn't seem to do anything. Well, that's because it created a file. So if it created a file, we hope, called output.txt, and there it is. So it created an external file. In fact, in the version that I'm going to post on the calendar, I'm going to have an extra call on print where I also send it to system.out. Because it's a print stream, so you can do it twice. You can print it to the file and print it to system.out. Okay, that's this example. It'll be on the calendar for today. It's a medium hint for the homework. I have just a few minutes left to be able to do one last thing. I told you at the beginning of the quarter that eventually we'd be able to understand this header of main, public static void main, string bracket bracket args. All right, well, we know the void part means it doesn't return anything. It's called main. It has a parameter called args that's of type string bracket bracket. So I'm going to put this on the calendar for today. It kind of is a way to figure out what's in string bracket bracket args. We've been using it all quarter. What's there? Let's take a look. So I'm going to print out what the length of args is and then have a little for loop that shows you what's inside of args. So let's see, anticipation all quarter. We've been wondering what's in this thing. Let's compile it and run it. It's empty. There's nothing in it. Well, that's because the way that we use Java in JGrasp, args is always going to be a zero-length string, a zero-length array, an empty array. So in order to understand it, and this is a really obscure thing, so this is not something that, if this seems a little bit weird to you or whatever, that's fine. You can totally forget this. I just want to kind of do my duty to try to explain it to you. You've been using a graphical user interface. You've been using a kind of this nice environment where you click on a button to compile and you click on a button to run. And JGrasp is, calls the programs for you, the Java compiler and the Java runtime system. Well, there's a different way of doing things, an older style of doing things that's known as a command line interface. I'm on a Macintosh, and so on my Mac, there's something known as Terminal that you can go into that lets you do a command line interface to give commands to Java, to my Mac. And there's a command called Java, which says run the Java runtime system, and you give it the name of a program, like show args. And so when I say Java show args, that's what JGrasp is doing, is that it's kind of running the Java runtime system, giving it the name of a program. But for people who are used to using a command line, they're used to potentially having extra kinds of things that you put after this. For example, the folks at Princeton are very fond of putting names of files like section.txt and output.txt. So that program we wrote a minute ago where we hard-coded a file name for section.txt and we hard-coded a file name for output.txt, they prefer to give those in the command line when you start up the program. You're going to do something different in what you're going to do in your programming assignment. You're going to prompt for these. But this would be another way to do it, would be to kind of put them after the name of the program. And notice that now args.length is 2, and those are the 2 things. I mean, you could have, how are you? You could kind of have a bunch more things, and now there's 5 things. So the args is for what we call command line arguments. And I can honestly tell you that, if in the decades that I've used Java, I've done this about once or twice. So it's not something that we use very often, but because you have the potential to use it, we've got to include the string bracket args. Okay, I'll put this on the calendar for today as well in case you're interested, and we'll do more next time.